Hello and welcome back to another video. In this problem, we're asked to sketch the graph of the function h of t is equal to the absolute value of t plus the absolute value of t plus 1. So with a more simple function, we can sort of use our basic knowledge of functions like the absolute value and apply transformations to it to find the actual graph of the function. However, in more complicated things, like when we're adding different absolute values, I think it is just the easiest to do plugging in points for t and find the values of h of t. So I think some good values will be -2, -1, 0, 1, and 2. I wrote them out of order, but that's okay. Now we just have to find them. H of -2, h of -1, h of 0, h of 1, and h of 2. That should be enough information to get our general graph. This is equal to the absolute value of -2 plus the absolute value of -2 plus 1. The absolute value of -2 is 2. -2 plus 1 is -1. Absolute value of -1 is +1. 2 plus 1 is 3. -1. The absolute value of -1 plus the absolute value of -1 plus 1. Absolute value of -1 is 1. -1 plus 1 is 0. The absolute value of 0 is 0. 0 plus 1 is equal to 1. H of 0. The absolute value of 0 plus the absolute value of 0 plus 1. The absolute value of 0 is 0. 0 plus 1 is 1. The absolute value of 1 is 1. So 0 plus 1 is 1. H of 1 is the absolute value of 1 plus the absolute value of 1 plus 1. This is getting very repetitive, but that's okay. Absolute value of 1 is 1. The absolute value of 1 plus 1 is 2. 1 plus 2 is 3. And finally, h of 2 is 2 plus the absolute value of 2 plus 1. Absolute value of 2 is 2. 2 plus 1 is 3. And this is equal to 5. So we have 3, 1, 1, 3, 5. Now we can graph the function based off of the points that we have. Just writing some points on the axes here for general reference. Okay, so we have -2, 3, that's going to go about there. -1, 1, 0, 1, 1, 3, and 2, 5. And we can see the general graph of an absolute value starting to form here. And we can just draw it just like this. That is the graph of the function h of t.